Welcome, guys. We're going to work on module 2 tonight. This is the basically the lecture portion of the module, where we go through the materials. These are our primary topics for this module. So we're going to look at relational operators, if statements, or what we call decision statements or selection statements, and the various different forms. We'll also look at logical operators and how they work, and of course, a lot of other little nuances. The slideshow kind of starts out with kind of a scenario to kind of maybe have you think a little bit about what we're about to do. And if you think back to our module 1 problem solving information where we talked about, problem solving and how there's basically 3 main ways to solve problems, right? Logical problems. One approach is to go step by step, right? So you do this, then you do that, then you do that, then the problem solves. The one that we're about to learn now is what I would call the second important technique for doing it, and that is what we call decision or selection statements. And that is where you are proceeding in a step-by-step fashion, but then you get to a fork in the road where you have to make a decision, and you're either following one path or you're following the other, right? And when you get to that fork in the road, you ask questions, right? And like, for example, my one goofy like pizza example, right? Where, if I have $20 in my pocket, then I can order pizza delivered. If I don't, well, then I'm making something at home, probably mac and cheese, right? And they can't both happen. You can do one or the other, but this process of making a decision is something that we face in coding. So they use this example here to talk about a pet store, and it's your job to recommend food for cats, right? And I don't know if you guys ever have, like, obviously they're picking at a very particular brand here, but if you ever shop for pet food, these are like the weird kind of choices you make, and pet food's expensive, so you don't want to waste time, selecting something that isn't the right food or doesn't sit well with your pet or isn't, the right calorie count or whatever, right? So what kind of questions would you ask a customer if you were guiding them to choose a particular type of food, right? So if you have a kitten, okay, you probably would choose this one, right? If you have a aging cat, you'd probably go with this one. If you have an adult cat, you might want to choose this one or that one, but it depends on if they're indoor or maybe they go out. I really don't know, right? Living in the city, I never think it's a good idea for your cat to go out or anywhere where there's cars, really, or predators for that matter, but that's just a personal opinion, right? But cats do get out, and some people have indoor outdoor cats, right? So and then you have ones, well, the ones that are eating a little bit too much and need a little cut back on the calories. So you'd have to like find a way to say, hey, is your cat like really portly? Is it like a 25 pounder? Maybe we should give it the overweight food, right? So these are the questions you ask, because why are you asking? Because you're trying to make a decision, and all of the questions that you're asking have yes, no answers, right? And those yes, no answers help you to determine your path. And because of the way the computers operate, those are the kind of questions that we ask to decide which path of code we're following. Are questions that only have yes, no answers or true, false answers. Right. So, all right. So that's the goofy little example, but it is one that you make. So if you guys like own a pet and you go to the pet store and you're shopping for food, I mean, these are things that you look at. I'm a big fan personally of buying well, not for my cats. The cats always get the same food. And I'm a big believer that you give them high quality food, because then it saves on the vet bills later. That's been my experience in life. You get them like the kitty chow, and then they're in the vet every few months. You get them high quality stuff, and they're not. But with my dog, I don't care as much, right? Because dogs are a little bit less finicky, and generally I try to switch brands and types of food for her just to keep her interested. Like whenever I get new food, she's like gets really excited. So, not that that's really important to what we're talking about, but we are looking at this first type of decision statement, which is basically an if statement. And this falls once again into what we call decision or selection structures. And what we've been doing so far is we've been doing the step by step. We've been doing the sequence approach, right? First do this, then do that, then do this, and you're successful, right? Um, However, right, there are circumstances in code that we don't want things to execute. And when we don't want them to execute, we have to come up with a mechanism for making the decision. And so here's the what I would call the simplest of all the decision structure, and that is we ask a question, and you can see the flow chart here, right? So we say, is it cold outside? It is. All right, we'll put a coat on. It's cold, right? If it's not cold, like today, I mean, it's like summer, and it's almost November. It's so weird. I was tempted to put on my shorts. The answer today was certainly no. And so you don't put a coat on. Notice you only execute the wear a coat action if the answer is yes. So if we answer yes to the yes, no, or true, false question, then we execute the code. If we don't, well, then we skip it. Right? Simple as that. Why would you put it on a coat if it's warm outside? You just wouldn't do it. Okay. The other thing is it cold outside? Well, your chances are if you're going to put on a coat, right? Probably want your gloves. Might not be a bad idea to have a hoodie or a hat too, right? And those are all separate steps. So you see, like choosing one fork in the road or one of the decision paths might actually beget a series of steps. It might not just be one thing happening, it might be a bunch of things happening. And actually, it could be a bunch of really complicated things happening. It just depends, right, on what it is. But this is a good example, once again, of like 3 actions happening or none. Because if it's warm, you don't need a hat, gloves, or a coat. I always have a saying in Wisconsin, though, even in July, you should probably bring a jacket, because all it takes is a cold wind off the lake, right? And that is Wisconsin, right? Frozen tundra and all that. All right. So we get to how do we do this in code, which is using what we call the if statement. If is a keyword which begets statements that ask yes or no questions, right? And most every programming language that I can think of, I mean, every programming language I can think of that has if else statements, if is the keyword that we use. Whenever we put a statement into code, it is followed by what we call a Boolean expression, meaning a statement that can be tested for true or false. Right. So where does the word Boolean come from? Do you guys remember there was a guy back in the 1800s who kind of figured this out, and his name was Boole. So the expression is Boolean. So like he came up with the concept of true false, but he's the one who expressed it mathematically. And man, how important it is in programming is huge. So with the if statement, whatever statement we're checking must resolve to true or false, however it happens. And then we decide on the course of action. Notice there's an expression, right, that follows the if statement, a set of curly brackets to enclose or encapsulate the code, and then whatever statements you have inside that if statement. That's the standard structure. If the expression that you throw in evaluates to false, these statements will not run. Just as simple as that. All right. When we start to evaluate if statements and the Boolean expressions, often we're doing logical comparisons. So we're looking at the value of numbers, or does one piece of text match up with another piece of text, that type of thing. And we're using these relational operators that we know from mathematics in order to express those logical tests, basically. So you have greater than, less than, Then you have greater than or equal, less than or equal. And notice how these are right next to each other. Like in mathematics, if you did this, you would do it a different way. You'd have the greater than sign with a slash underneath it, right? That's not how we do it in programming. Here we don't have a way to type that, so we combine them and type them next to each other, right? So greater than or equal to, or less than or equal to. And then here's the use of the double equal sign. I think we've talked about that real briefly last time. A single equal sign, remember, is what we call an assignment operator. It takes whatever's on the right side of the equal sign and then takes it and puts it in the variable or object or whatever that's on the left side of the equal sign, right? That's its purpose. When we put two of the equal signs together, now it behaves more like the one that we expect in mathematics. And I always say I always say equivalent to, that's how I think of it in my head, to separate it from the assignment operator. Remember, single equal sign assigns variables, double equal sign tests to see if things are equivalent, right? We also have the negated or the not equal to sign. So it's exclamation equals. The exclamation sign can also be used standalone to negate any true false value, like a Boolean, or we'll look at that in just a few moments. There is a precedence in how these operate. Okay, so this is kind of weird that somebody would even think about this, but greater than and less than, terminology basically, or comparisons, operate at a higher level than the equivalency ones if they're combined into the same statements. Usually you're only using one comparison operator at a time, but if you're curious about the order in which they process, there you go, right? I don't worry my head about it too much. Some of the kind of equal things here, right, are when we look at like doing a comparison, and I look at, for example, this concept of like length and width, right? And you think of like the length and the width of a room. We don't know what those values are, but they're different for every room, right? Some rooms are square, some are really long and narrow, some are really wide and short or whatever. And then you put them on a chart like this, and then I want you to look at basically what they're highlighting here is that when you get to the greater than or equal to, right, and the or is highlighted, right? This implies equal to, this implies not equal to, greater than, less than. But with these, you're really doing two comparisons. You're checking either is it greater or is it the same? You see the distinction there, right? So you got to be careful in the usage of this one, because it can either work against you or for you depending on your logic. And because it has an implied or inside of it, that really is part of it. It's really testing two things at the same time, if you think of it that way, right? Right. And so this is kind of what they're trying to explain here, that it tests two things. Is it greater than or is it equal to? Is it less than or is it equal to? Two different things, but both are valid and part of the equation. So is 5 less than or equal to 9? Is that true? It is, right? Because the 5 is less than. That part of it's true. Is the 9 less than or equal to 9? Well, duh, it's equal. Yeah, so yeah, it's equal. But notice how it can't be both. This one, right, it's the less than that's kicking in. This one, it's the equals to that's kicking in. But only one of those needs to be true because we're working with a logical or. We're going to talk about this in a second, right? So, and what that means. All right. So, for example, if I was writing the snippet of code and I put together an integer called grade, I set it equal to 10. Then I run my logical test to say if, notice the parens, right? If the grade is greater than or equal to 9, is that true? Well, it is, right? Because 10 is greater than for sure. Then we're going to output good work. Okay. So what happens if the grade is 5?
It doesn't,
Nothing
right?
will happen. Yeah, say that again, Teresa.
I just said it doesn't right line.
Yeah, right. Because if it happens to be five, it's just going to skip. It's going to, do this, and then it's just going to skip the rest of it. So this doesn't happen. What happens next, we don't know, but it certainly doesn't do that. Right. That's if we're just running an if statement. All right. So let's try doing some of this stuff here. Let's see if we can actually do these little sample programs. And I'm just trying to see if I have an example on that one. I don't think I have an example of that one. That's all right. Let's go and see if we can kind of do this. So I'm just going to create a new project. I'm going to call it, what are we going to call this? Calories per day. Sound pretty good? Putting it in the same folder, folks. Delete all that stuff. It says create a console program to average three values. For this program, we will ask the user for the number of calories consumed on 3 consecutive days. Declare 3 integers. Prompt the user to enter these values. So we're going to say calories day 1, day 2, day 3. So like we can probably copy that as a prompt, right? And then print out the total and average with the average print high. All right, so I think I have a lay of the land here. But if you want, you could always move this to your other screen. So I'm going to move this to my other screen just so I can see the instructions here, and then I'm going to start coding. So let's start by just doing some simple console.writes, doing a prompt, and let's just say calories day 1, I think is how they put it, right? Yep. And if you want, you could always copy that from the slide so you don't have to type it. It's not cheating. All right. Are we converting to an integer on this? What do you guys think? I think so, right? I'm just borrowing from our other program here. So what am I going to call this? Cal1, maybe? And we're going to do this 2 more times. So I'm just going to copy paste that twice. I'm going to change the variable names. And then I'm going to change the prompt so we know that something happened. There's our 3 prompts. All right. And actually, they wanted us to call them val1, val2, val3. Right. Okay. I called them something different, but I called them cal1, cal2, cal3. Same difference. All right. Now we have to do some math. First, we have to total them, right? So why don't we set up a variable called total, and then we're just going to add cal1 plus cal2 plus, notice how it's like auto completing for me, and I'm just going with it. I'm just hitting tab and accepting it, right? So there's our total. Then we also need to do an average. Now, okay, so here comes a question we haven't really talked about much. Should the average be a whole number, or should it be maybe a double? I'm going to make it a double, and we'll talk about why I'm doing that. I'm going to abbreviate this and call it average. And how do you get the average of something? You take the total, right, and divide it by the total number that we have, which is 3. All right. And then we just want to do output statements. So we're just going to do console dot write line, and then we're going to say something goofy like the total number of calories is, And then if you want to use string interpolation, which is probably the smart thing to do, don't forget to put your $sign here. This is the way I would prefer to do it for something like this. All right. The next output, once again, let's use string interpolation. And you may as well close out the statement so you get rid of the goofy warnings here. We can say the average number of calories per day is what's that one called? Average. All right, so we're dropping that in. Another thing that is happening though, and I don't know if you guys caught this in the description, it says print out the total and the average, which I just did, with the average print high if above 2,500 and low if below. So, and I'm going to say, which is, okay, we don't know what it is, but we're going to write another if statement here to figure that out. So I'm going to say, all right, if the average, and notice how it's just completing for me, is above 2,500, and notice the curly brackets there, and see how Microsoft makes me format it. They have their own way of formatting stuff. So if the average is above 2,500, why don't we create a string variable called, how about answer, which will say hi. If the average is less than 2,500, oops, forgot my curly brackets there. And you notice how Visual Studio, you type the opening curly bracket, it types the other one for you immediately, right? And then our other issue here is, right, and it doesn't like it when I use it twice like that, but hey, we're just going to go with it. But then we have to have this discussion, right? So I have the one set up for high, the other set up for low. But what happens if the calorie count is exactly 2,500? Interesting, right? I mean, you got to pick one or the other that's going to be included. I think if you hit 2,500, I'll call that high. So I'm going to say greater than or equal to. I think that would be my choice. All right. So here, now I can put the other variable called answer. And probably a period is probably good. And actually, I think they wanted us to do this. Maybe caps. So there it is. What is this saying? Aha, doesn't exist in the current context. So why is it doing that, folks?
Because we didn't declare the answer. We did string design.
Yeah, say that a little louder. Your voice is breaking up.
We didn't declare the answer.
Yeah, and really,
before the if statement.
Yeah, you are directly onto it because it's inside of a code block. C# doesn't see it. Now, the reason I do that little example there is for a very specific reason, because if I was doing this, for example, in Python would allow me to do it inside the if statement. Have any of you taken Python before this class?
I've studied some Python.
Yeah, I know a lot of people have, right? And I get it. But in this language, you do have to do it this way. Notice how the underline goes away, right? Yeah, the underline goes away. So now we can run the code. So here's the little example program. Here it comes up on the screen. I'm just going to move it off to the side here. And I'll also do this so you can see all the statements. All right. And we do have an example, and I don't know if the example is numerically correct. So it's 2345, 3122, and 1995. Okay, which is low. Yeah, I came up, well, I came up with the same numbers, but this is not rounding, right? So this is actually, we see a rounded answer, but I'll tell you what, it's pretty close to 2,500. I really don't care what the decimal points are, but we could format it, right? And we can kind of review our notes on that. I'm not too worried about that right now. The more important part are the if statements on this one. All right. So that kind of gives us the impetus here that we can follow these branches. And you notice how like Visual Studio is trying to type else for me, because that might have been a better solution, but we haven't learned that yet. That's coming up. All right. So this is that first little example. I'm going to save that, and then we'll come back to it in a bit. All right. Bringing that PowerPoint back over, folks. All right. So a couple of things that you get warnings on here. When you are typing your if statements, be careful with where you put your semicolons. This is kind of an interesting thought, right? There is, especially if you've gotten used to coding Python once again, right? Python would put a colon in this spot, and then all of its sub statements are just indented. You don't need the curly brackets. But with C#, you do not want a semicolon here. The if statement is basically a code block because of the curly brackets, and only the statements inside of it need the curly bracket. There's no semicolon here, for example, right? But there's also not one there. If you're doing multiple statements, notice each one of the statements inside the if statement, each has its own semicolon at the end. They each will execute just like normal code, top to bottom. So this one will go first, second, and third. And they will only run if this expression appears true. Now, one technique that coders do use, right, is we use this thing that we call flags, right? And or we maybe sentinels or markers or something like that. And basically what flags are Boolean values that we set up so that we can trigger to be true or false on purpose, right? So like, for example, look at this. If you're a student and you get above a 95, that would be considered a good grade and we'd call you a good student. But we're not going to assume that to start. In fact, we're going to preset good student to false. Then we check your grade. And if you clear that threshold, then we'll call you a good student. If you don't reach that level, well, you're probably an okay student. Right? Not that there's anything wrong with that, but I'm just kind of using that example. So if you were to use that in your code, and this is where these Boolean values are kind of useful because they're already a true false. So I don't have to type a whole expression. If you guys feel what I'm saying, I can just check to see if good student, which means if good student is true, is what that converts to, then you can get the student discount. All right, we're gonna do a couple more slides here and then we're gonna take a break. So another thing that you can do is you can do comparisons not only with numbers. So when you see those mathematical symbols, which is, logical, right? Like greater than or less than, immediately you think numbers, right? And that you can compare, well, like 5 is greater than 4. I mean, that makes sense. But did you know that you can also compare the letters that way too? So if I set a character to be the letter F, and then I compare that letter to see if it's greater than E, that would be true, right? and it works alphabetically, but I will just have you remember that we kind of looked at this real briefly last time, the Unicode thing, and basically that any of the characters on the keyboard, like the letter A is a value of 65, the letter E is 69, F is 70. So is F greater than E? The answer is yes, right? Because all the stuff converts to numbers anyhow, according to this chart, right? And then notice that the weirdness is the lowercase letters have greater values than the uppercase letters. That's a little weird. So you have to accommodate for that when you're coding, by the way, to alphabetize. And there's whole sorting algorithms and stuff that are built around that. But yeah, you can do that. So you can compare letters, and you can even take it further and you can compare strings, right? So here's an example that we have here about the curly brackets now. So when we're formatting our code, you notice that Visual Studio forced me to follow this format. It wasn't even a choice. I put my curly bracket here because that's what I'm used to from Java and JavaScript and a bunch of other languages. And then the moment I pressed, the curly bracket in, it auto typed the closing one. I pressed enter and it split them just like this and put the cursor here ready for me to type. So Visual Studio will do this automatically. This is perfectly fine too, though, to just use that approach where the curly bracket starts here and ends there. And actually, you could even do it like this. And I'm going to be kind of weird and do it right inside the PowerPoint, but you can even do it like this. And technically that's valid too, right? And this teaches us something about the languages and the coding tools. And basically what it's showing us is that how the coding tool displays the code is really for our benefit, not for the execution of the code. The computer doesn't care. But our eyes sure care when we're looking at code and it gets complicated and long. Having it formatted nicely sure makes it easier to look at. That's the whole point. All right, folks, we're going to do a 5-minute break. So I'm going to pause the video here. All right, let's come back from break now and continue on with our materials. We're going to move on to this, the second thing that we're going to add to the if statement, which is the else component. So when we looked at the first example, we just did an if statement, basically where we got to the decision point and there was only an action on one branch, right? So that, like, if we hit the true, then we would put an action in there that we would execute, otherwise we'd skip it. Well, what if, we ask this question, is it cold outside and you wear a coat? Or like I have a few friends who, like, if it's basically above like 50 degrees, they're wearing shorts. I'm sure you probably know people like that too, right? The example they're using is sandals, right? But is it cold outside? If you say yes, you wear a coat, hat and gloves probably too. And if not, then you're going to wear sandals. But now there's a action that happens on the no side or the negative side. So that would translate to what happens if the if is false, So if it resolves to false, then we have an alternate pathway. In code, it'll look like this. So we do the comparison with the E and the F again. And if F is greater than E, then it will indicate here, well, it comes after E. F comes after E. Otherwise, we say it does not. Right? But what if that changes? What if the letter was D? So is D greater than E? And the answer would be no. And in that case, it does not come after E, it comes before. So the else would execute. Notice that we're not checking another condition here. It is because this condition is false that we're taking this pathway. All right. All right. If the if part is the same as before, the else part does not have a Boolean expression of its own. So that's what I just showed. So, because we're taking one branch or the other, I don't need to ask a second question. The question's already been answered, just a matter of which path we're following, right? So if doesn't become true, else automatically happens in that situation. Here's kind of another thing, and they probably should have put this slide up above, right? They're talking about optional curly braces. And what I'm just going to warn all of you, especially if you're new to a language with curly braces, is careful with this feature, right? This is true in other C style languages also. And that is if there's only one statement inside the if part, or there's only one statement inside the else part, I don't need the curly brackets. It works just fine without, right? If you start adding more than one statement, right? Um, then you want the curly brackets. But here's kind of the danger of this, because if you're going without the curly brackets, what's going to happen in this situation is this will run, right? If it's true, this looks like it's part of the if statement, but it's not, right? That's the danger. And so if you intend this statement to be part of that one, you better use the curly brackets. So what I generally say to my students is put the curly brackets in every time. You're more apt to add more code than not. If it's a really simple statement like this, okay, I get it. Go with this, right? But this one has the danger of breaking because you forgot the curly brackets. So just
Okay,
fair warning.
so curly brackets will come after, it'll be if curly bracket, console curly bracket, else curly bracket, console.
For the else part of the statement.
Yeah.
Yeah. Oh, okay. Well, so for example, right, this is kind of equivalent to really doing this, right?
Okay, perfect. That's what I
Okay.
got.
And the same thing is true of the else. And you see, like, it's trying to auto type for me here, but these are
Perfect.
functionally equivalent, right? So I would do it like that, right?
Gotcha.
And this style where the curly brackets on the same line with the if or the else, that's kind of like the Java style. And remember, the Microsoft style will look like this,
Okay, thank you.
right? And there's no right or wrong here, but you can see, like, for example, if I decide to get smart and add extra stuff later, then it can break. And that's kind of the point they're trying to make here, is really there should be curly brackets around this statement, right? This one, the way this is written, this one will always print even if the statement's not true, because it's not part of the if statement. It looks like it is. And then once again, if you're used to Python, where Python controls if statements with indents, right? If it's indented, then it's part of the if statement. Not true in C#. It is a curly bracket language. And once again, kind of reinforcing this concept of, the way it looks in the coding engine has nothing to do with how it operates in this language. So let's take a look at this scenario here where we start asking some more complicated questions. So it says, applying for a loan. A bank customer is applying for a loan. To qualify, you have to have two criteria that you meet. You got to make at least 50K a year, and you need to be at your job for at least 2 years. Right? They want to see like steady income, and if you reach that level, you're probably pretty stable and probably can handle a home loan, right? So how would the conversation go between the customer and the loan officer? And believe it or not, a lot of banks have flowcharts just like this, and a lot of call centers have flowcharts just like this that they actually follow, right? So they ask the yes, no questions. First question is your salary greater than or equal to 50,000? All right. Well, if the answer is no or false, then okay, well, too bad, too sad. Can't buy a house, you're renting, right? If the answer is yes, then you move on to question number two. Have you been at your job for 2 years or more? If yes, then you're qualified to sign up for a loan. If not, you are once again disqualified. All right. So notice that there's really two ifs that are happening here. The first one happens, and then as part of the true branch, we have another if inside of it with its own two pathways. So this is an if else, right? And this one's an if else, but this if else is nested inside the first one, right? So, all right. So if you want to try to convert this to code, right? So we ask the first question, right? Is the salary greater than 50,000 or not? All right. Let's say it's not, you're disqualified, but what if it is? What goes there? Well, notice that here it says if you put one if statement inside the other braces of another, only the one inside will only be tested if the outside one is true, just like the salary and the number of years at work. So if we convert all of that to code, we clear the first hurdle. So we say yes to this. And now we move on to the next question, which is, are you saying yes to this? And if you are, then you're qualified. Otherwise, you're disqualified. Right. So this is a what we call a nested if statement. It's nested inside the other. Really kind of weird, but you can kind of do this. You can go pretty deep with this, right? So how many if statements can you nest inside of another? As many as you can conceive and structure into your code is the answer. I do find that what typically happens with most normal human beings is they can kind of figure it out like 2 or 3 or 4, maybe 5 layers deep, and then their brain starts to break down on it because our brains don't like to think like that. Right. But often, and I'll have you kind of like think about like the rock, paper, scissors scenario again, right? Like the 5-year-olds explaining the game to each other. That game actually goes pretty deep like that, right? If you put up rock and you put up scissors, what happens? That's kind of the example. All right. So in terms of programming style, it says C# does not enforce indentation. We've talked about that. So you don't really have to indent your code. Everything is really controlled by the curly braces in this language, right? As a juxtaposition to Python where the indenting does matter, right? And that's more of an anomalous language, by the way. It says it's best to practice indent statements one level under the if or else, right? And basically a reiteration. We do that to make it look easy for us to read. The computer doesn't care, right? I say this to my students when we do HTML code too, right? Like you structure that often to look really nice and neat for your own eyes, but the browser doesn't care. If you start getting weird and omitting the curly braces, it can be hard to track which else goes with which if, right? Especially if you use the ones that only have one statement inside of it, and then you skip the curly brackets. My general rule of thumb is always use the curly brackets, right? It really saves a lot of headache and hassle as you make things complex. And just to kind of drive home that point, take a look at this example, right? Here's an if else, which is this. This is a complete if else that's nested inside the if part of the outer if else, but there's no curly brackets, not needed. The indentation isn't needed either, but notice how difficult this is to kind of look at and figure out. Just because visually it's not indented and you can't see what's inside something else. So it really does help with the curly brackets. It really does help with the indentation. But if you kind of follow the logic here, it's the same questions we had before. Is that true? Okay, if that's true, then we ask this, is this true? Yes, it is. And then we do that. But the else that happens here goes with this if. That else goes with this if. So that's where it gets confusing, and why we generally, I'd put a big red X through this and say, don't do this, right? Not that it won't work. It'll work just fine. Now, if you're coding with an engine other than Visual Studio, it's not going to force you to indent it. Visual Studio, as you can tell when you're typing, it kind of does it automatically. And what you do when your IDE does it automatically is you let go of the wheel and you let it do it. It's like if you have a car with lane correction, and you're about to smash into the sidewall, you let it fix your lane, right? You don't, take control back. All right. There is an alternative approach to doing what we call an if else and then nesting another if else inside of it. right? And this is where we go to if, else, if, right? Where we do a check and then we say else if, and we do another logical test. And really the kind of scenario that we're talking about here is something like this. So this is an example of like determining somebody's grade, right? And we ask a series of questions. And okay, so for example, is your score less than 60? All right, well, if that's true, I'm sorry, you got an F. All right, that's pretty standard college grading scale, by the way. All right, well, no, it's higher than 60. All right, so you move on to the next question. Is your score less than 70? Now, keep in mind, we know it's not less than 60 at this point. So now we know it's between 60 and 70. See the logic there, right? The cleverness of it. And so, all right, well, if you're less than 70, but you're greater than 60, is really what we're saying, then you get a D. Then we go to 80. Then we go to 90. And then if none of those catch, well, the default then is you get an A, right? Because we know you're above 90. So you get some form of an A. Of course, it'd probably be an A minus, or if it's the low 90s. But the whole point is we ask a series of questions, and if any one of the questions comes true, we take a course of action, but ultimately we have a final else at the end. So we would say, like, for example, if score is less than or equal to 60, then grade F. Else, if the score is less than or equal to 70, it's a D. Else, if you see the kind of pattern I'm forming there, and then if you look at the next slide, there it is converted to code. We ask the first question, we ask the second question as an else if, and what this does is it forms this logical structure. So there's a pathway we follow if any of the conditions we hit make sense. And then if none of those conditions hit, then we have a default. We don't need to check this because at that point we know they're above 90, right? So I don't have to ask if score is greater than 90. Unnecessary. It's automatically greater than 90 when you reach this point. So this is where like the logical leap comes in. And this kind of thing, especially when it's like graduated values like this is the kind of thing that you kind of learn to do intuitively when you become an experienced programmer. But when you see it initially, it's kind of like, okay, I don't get it. I'm not sure why you did it that way. But when you think about it from a logical perspective, this makes sense. The other possibility, right, for this one is we could flip it. So the first question could be, is your score greater than or equal to 90? You get an A. Is your score greater than or equal to 80? You see right? I'm reversing the order, but I'm also reversing the logic that I'm checking. And that once again comes with experience. Either approach would work to give you the right answer. But if I flip it to the other approach, the default then would be an F, right? But if they clear one of the other hurdles, it wouldn't be. All right, so I think that maybe we try to build this one and see what we get. All right, so let's try coding this. So let's read through it first. And this says, write an if else if statement that evaluates the temperature and prints a reaction, right? So it should provide at least 3 responses. For example, way too cold, a little chilly, good hiking weather. That's it. I'm moving, for example, right? Use a final else to provide a default reaction. If you have time, modify the program to ask for the temperature. All right, and I think I have an example. Maybe have an example. All right. So I have an example I'm going to work from, and I am going to use a temperature for this because to me it makes sense to do so. And so let's go ahead. I'm going to close this solution. I'm going to create a new project once again. I'm going to call this, how about temp check mod 2 This is for my own sake, so I know what it belongs with. All right, and get rid of the default contents here. First thing I'm going to do is I'm going to create an integer called temp, and I'm going to preset it to 70. Oh, let's preset it to 60 degrees. All right, we can change this to play with it. All right, so then I can just start doing a prompt. So for example, I might say something like this to start. I'm doing a copy paste here, by the way. So if the temperature is less than minus 26, that's it. I'm moving to Florida. The last time we saw a temperature like that around here. Been a while, actually. Last year was the winter without snow. I think I shoveled twice or something crazy like that. All right. Else if the temperature is less than 10, all right, let's go ice fishing because the ice will be nice and stable and thick at that point. But I don't know if any of you guys do that. All right. And you can come up with, whatever temperature gradations you wish, by the way. Here's another one that I decided to do. Else, if the temperature is under 60, okay, I think that's good working weather, honestly, right? Like if you're outside doing something physical, I mean, anything like between like 20 degrees and 60 degrees is to me ideal. I can work without a coat pretty much. Well, maybe 30. All right. You can come up with whatever temperature points you want and come up with whatever statements you want. That's on you. Here's another one. Let's accommodate for if it's really hot. The temperature is greater than 90. And then there's another statement which finishes it off. And I'm going to, oops, I apologize. Right there. It's beautiful outside. Now, I want you to think about the implication here that I'm saying that any temperature between 60 and 90 it's beautiful outside. And I do feel that way, right? That's like the ideal temperature range. Pushing 90 is a little warm, but I'll suffer through it. I'll put on my shorts and my sandals and I'll suffer through it. All right. So if it's 60 degrees outside, what's the response going to be? All right. It's beautiful outside. Now, what you could do, and I'm just kind of pointing this out, is you could prompt the user for this value. They can tell you what the temperature is, and then it would fall into that thing. You want to test it. You want to put in like a minus 50, right? You notice that's it. I'm moving to Florida. And that's what I would do with this basically is I would try some temperatures. So I would put in maybe 5 degrees. And what I would do is I would try to trigger each one of the scenarios, right? And I'm just going to keep doing it. So this one I'll set, oh, I didn't change it. Let's set this one to 52. Good working weather. Now let's set it to 72.
Oh,
It's beautiful outside. So it's hitting the last one, right? And now let's change it to 92 and see if it says it's hot outside. Boy, is it hot. Okay, so all the scenarios work. But notice that we are employing that logic. And instead of following just a straight sequential approach, like in the grading thing, I also took one of the signs and flipped it, implying that there's a good range that this one falls into. So I could check it as a range, but these are all logic questions, you guys. How you arrange it doesn't really matter as long as the logic works. That's kind of the thought, right? So this is an example of a if else is what I would call it. Everybody okay? Everybody's worked? All right. Now, sometimes I get kind and I do this. So I'm just going to do it. This is just an example, mind you, right? I'm going to copy this code and drop it into the chat for you. So this is only for the students that are here in the session. So there you go. If you want to try the code, there it is. moving on with the materials, folks. I'm going to move on to logical operators now. And here's where we start to think about and something beyond like the greater than, less than, equal to, or not equal to. Here's where we are dealing with still checking those things, but also looking to make sure that multiple conditions are checked. So I want you to think about like what we just did here in code, right? Before I can get to like it's beautiful outside, think of all the conditions I'm checking. So I'm saying that the temperature is not less than 26, not less than 10, not less than 60, and not greater than 90. I want you to hear how I'm saying that, because I'm using the word and in between each one of those statements. So if this is not true, and this is not true, and this is not true, and this is not true, then it's between 60 and 70 and we get this result, right? But the fact is, whenever I use the keyword and, both conditions have to be true. So for example, if I need to make cake and my recipe calls for eggs and water, I need to have both of those things. Do you have eggs? True or false? Do you have water? True or false? I need both to be true to make the cake. That's what we call a logical and. This is expressed in coding, by the way, with a double ampersand. So the two of them together, and that gives us our logical and. They call this a binary operator, by the way. But whatever happens with that equation, both things have to be true. And they come up with this little truth table of all the possibilities, because if I'm checking one thing to be true and one thing also to be true, the reality is there's 4 possibilities, but you notice that I need all of or both of the things to be true in order to be true. So only 1 out of 4 is going to work. See the logic there? That's what the table's about, right? So if I don't have water and I don't have eggs, either one of those makes the statement false. But if I have both, only one of those makes it true. All right. There's also sometimes what we call the or statements, and this is what we were looking at before with the greater than or equal to, or less than or equal to, right? Why that's a binary or a double check there. So my recipe also says if I want, I could use oil in the recipe to make the cake, or I can use applesauce. So if I'm out of oil and I have applesauce, I'm fine. Only one of the things in a logical or needs to be true, right? And when we code that, this looks like this. It's 2 pipes. And if you don't know where that is in your keyboard, look above your enter key. On the backslash key, it's the shift of the backslash key. And those are called pipes, by the way. 2 of them together represents a logical or. With an or, only one of the expressions needs to be true. For example, is 5 less than or equal to 9? Well, it's less than. That part's true, so the statement is true. Is 9 greater than or equal to 9? Well, it's equal to. It's not greater than. Only one is true, so the whole statement is true. Now, in an or expression, you might have an expression where both sides of the or evaluate to true, and that's fine. And then you notice with an or, it's much more likely to get a positive result because it only takes one true in each column to trigger it to truth. So that's going to be true 75% of the time, in principle, right? And at least in the terms of sheer possibility. So if I have applesauce or oil, I'm good. The only problem is if I don't have either one, right? Then I'm looking for a third alternative, which probably isn't going to happen. All right, let's jump back to the loan approval thing and let's see how this applies in this kind of a situation. Because think about the loan thing, they're really asking 2 questions that really need to be true for the person to get the loan. Okay, so if the salary is more than 50K and double ampersand, right? You've been working there for more than 2 years, or at least 2 years is really how that reads. Right. And really it reads salary at least 50K, years at least 2. Right. Then you're qualified. Both conditions must be true for that to be happening. Isn't this a more efficient way to write the statement than the if salary greater than, then do another if statement? Yeah, it is more efficient. In essence, we're really doing the same check though. You see the logic there? So once again, an experienced programmer will recognize this, save themselves a nested if statement and put it in one combination logical statement with a logical and. Both must be true for it to evaluate to true. All right. Here's another example. This one uses the logical or though, and I like the example a lot because, you know, a tropical fish, right? If you guys have ever owned any, we've tried that a few times. We're not very good with fish. We're good with other pets, not with fish, it seems. But they're very temperature sensitive. So if your house is really cold and drafty or really hot or whatever, it can be problematic because they have to be in water that's between 72 and 80 degrees. That's a very narrow temperature range. So if the temperature is less than 72 or the temperature is greater than 80, danger, Will Robinson. You know, those fish are going to either, you know, die from heat or from freezing, right? Otherwise, what's the implication? The else for this is that the temperature is between 72 and 80, right? That's a given. So notice that this one makes a lot of sense to be an or because the ends of the temperature range are mutually exclusive. It can't be like less than 72 and greater than 80. See the logic there? Right? We're trying to hit the zone in the middle. So this is a clever way to hit the zone in the middle. Once again, this sort of like logical structure in terms of how you're checking it is one of those things that, you know, if you're writing the code from scratch, this is a concept where experienced programmers see this stuff, right? And then people who are new to it have to think about it a little bit, and that's okay, right? There's a process to getting here. So this is a really nice little example. I like this one a lot. All right, another thought to think about is we have this operator as well. So we had the double ampersand, the double pipes, so ands and ors, but we also have a logical operator called not, which is the exclamation point, right? And so we can use this adjacent to any type of Boolean value to negate it. So for example, if I set up a Boolean called valid and set it to true, this if statement is checking for false, right? Or not true, right? It's flipping the value of it. So it's looking for false, right? Or in this case, we're looking, well, this says if the temperature is under 32, put the negation symbol in front of it, and that means 32 or above, right? See the logic there, right? And okay, so why would we use this? Why not just set this to false? Because we might not have that control. Sometimes it makes sense to refer to the things in the negative or the reverse fashion in the logic, right? This comes with a little experience once again also, but think about it. The temperature is less than 32, it freezes, but we're looking for it to not be less than 32, in which case it's liquid. So that's the logical not. In terms of how they process, right? And once again, like my take on this is I kind of don't care. Be real, I don't care what order they process in as long as it works. But if you do care, this is the order of precedence. So logical nots happen first, then ands, then ors. Now, why it's important with ands and ors, because it is possible to write logic statements that have more than just two values, that might have 3 or 4 logical tests where you mix ands and ors. So this is kind of the next thought here, right? So like take our scenario. I've got water. Well, I need water and eggs. Those have to be true. And so notice, and I need oil or applesauce. Now think of how the statements go here. So if it's like true, false, true, true. Okay. Okay. This is really kind of hard to read, but the order of precedence would say that we're evaluating ands first. So I would evaluate this and then that's true. And then I'm evaluating with this, which might be true. And then I'm evaluating with that, which might also be true. So which order is it going in? That's kind of the problem. The suggestion is what we're really trying to do here is that we're trying to isolate the oil and the applesauce in one statement. So sometimes you have to use parentheses to do more complex statements. So first we check this, it evaluates. Since this is all true, then we're trying to evaluate it against this, but it's one or the other with this one. Only one has to be true.
So I'm assuming that we don't have two eggs. That's why it's false, right?
Yeah, it's not really telling us why, right? Yeah, I mean, this is kind of we don't have two eggs. We have one. Let's say you have one egg, and these are kind of like goofy little examples, but the point generally is that the ors kind of operate against each other first. So if you want to make sure that happens, just like in mathematics, parentheses helps, right? You want to check this first. All right, check this first, because if both of these are false, we got problems, right? Yeah, we got problems if both of those are false. All right. All right, let's move on to comparing strings here. We don't have too many more slides left, so we might even get to doing a little bit of the lab work tonight. We'll see, right? I might also opt to maybe call it a night early. I don't know how you guys feel about that. I'm sure you won't complain. We'll see when we get there. All right. All right. The next little section is comparing strings. And now, when we're using all the typical comparison operators, we never usually think that, okay, well, we can do mathematical operators on strings. We looked at it a little bit with the letters E and F and D and stuff before. But yeah, we can check to see if strings are equivalent. Just for example, here they're comparing two names, double equal sign. So they have to be exactly the same, and then it triggers same. Notice that there's also what we call an equals method. And these basically do functionally the same thing. So we take one string, equals is a method or a function that works with strings. We put the other string into it, and we're checking, does name2 equal name1? The result of that operation is true or false, just like the result of this operation. So if you see this sort of verbiage, you're good. If you see this sort of verbiage, functionally the same. Right. So either approach is perfectly acceptable. Right. Same is true with the negation symbol. So if I want to do name1 does not equal name2, right, I can just do it with the standard not equal sign, or I can use the equal statement and then put a negation sign in front of it. Right. My only issue with this one is, and I just say this from my own practical usage, is sometimes when I use this approach, I sometimes don't see that character because it's one character on the screen, where this I see a lot better because it usually I put spaces around it, so I see it more, right? That's my take on it, right? So take that for what it's worth. These are easy to miss, but these are functionally the same statement once again. We can do greater than or less than with strings too, for the same reason we talked about before, which is if you look at the Unicode numbers of the alphabet that have numeric value to them, we can take an entire string and compare them, right? However, okay, so notice if I use this approach, right, I can't compare to see if like name1 is greater than name2. It won't compile, right? You're going to throw an error with that approach. So what they did is they built a compare function or method, once again, where we attach it, right, basically to this. This does return an integer result, which is kind of strange, but basically I take both of my strings and drop them in here. It compares them to see if they're the same or if one is greater than the other or less than the other. This is weird, right? And then it returns an integer, not a true false. So it's going to return an integer in one of three values. And typically, by the way, it's -1, 0, or +1. So there's three branches here that can happen. One is if it's negative, first one is less than name 2, which means it's alphabetically preceding name 2. If the result is positive, a positive one, that means name 1 is greater than or comes after name 2 in terms of being alphabetic. And if it's 0, then they're the same. Now, this is particularly useful, right? For a lot of different things, but it also allows you to compare the strings looking for the answer of 0 to see if they're the same. Kind of interesting, right? So pretty darn useful, actually, in a really practical sense. So when you're doing a comparison, so here's an example. We do the comparison. It throws a value in here, so it's either positive, negative, or 0. So we check to see if it's less than 0 or negative, right? It says name 1 before, check to see if it's greater than, name 1 after, checks to see if they do the same, and name 1 is equal, right? So that's an example of some of the code you might write with the compare statement. You could also write code that doesn't address all the different values, but only the one that you want, right? Like if they're the same, or if it's before or after, that kind of thing. How do they actually do string comparisons? And this is kind of like the standard alphabetization approach is like, what if you have Mark and Mary, both have capital M's, both have A's, both have R's, but then you get to the fourth letter, which is finally the first one that's different. The K comes before the Y. So Mark is less than Mary. That's why it comes before, right? It's got a smaller number attached to the letter K. Y is a higher number in that Unicode list. And so that's how it determines if things are alphabetized, right? And I think this is really clever because this is how, the computer figures out if things are in order versus the way that we were taught. How were we taught? We didn't apply numbers to the letters. We just had to learn the order of the letters and memorize it, which is kind of weird, right? The computer approach is actually more logical because there's a numerical value attached to it. If you happen to be comparing strings that have the same letters encapsulated in both, but one word is longer than the other, the one with the shorter word comes first in an alphabetical order. All right. And that is the PowerPoint, folks. So I'm going to go ahead and I'm going to stop the recording here. So that's all the module 2 lecture materials for now.